All right, good afternoon and welcome to today's lecture. This is lecture 6. Today we're going to talk a little bit about inheritance, and then we're going to look at some specifics of how those things can be accomplished in Java in particular. The first part of the lecture will look on the concept broadly, and then the second part of the lecture will focus a little bit more on implementation using our language of choice, as I just said, which is Java. All right, so we're going to start off by looking at deriving subclasses. We're going to look at what is inherited when we do that. We're going to look at method overriding, and then we're going to look at Java class hierarchy. All right, in general, inheritance is similar to what we understand to be in regular life, where a parent has a child and the child is going to have some of the characteristics of the parent. It's a similar concept. But let us look at the programming example where a class, maybe we can call it person, represents some individual or the blueprint for an individual. And that class defines such characteristics as a name, a year of birth, sex, and so on. So in a sense, if we're to relate that to an application, we might want to say that every person might have those characteristics. Now consider a student, right? Who is a person, right? That student will have all the things that are provided for in a person, but they might have additional things about them that distinguishes them as a student, yes? Now, this is an example of inheritance, and we're going to explore more of that. So in OOP, a new class can be written by simply extending or inheriting from an existing class. The new class has the characteristics of the class that it extends, plus any other characteristic that is defined locally in that new class. Okay? So in the case that I spoke of before, a class student that inherits from person will have all the characteristics of the person in addition to any characteristics that are specifically defined in the student class by itself. All right? The new class is said to be derived from the initial class or that was extended, and extended class can be also referred to as a parent class or as a superclass, and of course the new class is called child or subclass. All right, just be aware of the different terminologies. All right, so sometimes we might refer to them as a derived class, a child class, or a subclass. And in the case of the parent class, it can also be referred to as a superclass, or I mean, there are some other terminologies that we will introduce you to when we look at other types of classes. But that is to come. Now, last week we spoke a little bit about UML, and we discussed UML diagrams. Now, in trying to represent inheritance in UML, we use a arrow with an empty fill-in so that it's a full arrow, but it's not shaded. All right. And now in this case, what essentially is being communicated by this diagram here is that person is the superclass and student is the child class, right? And so everything in person will also be in student because student inherits everything from person, okay? There are some specific things that we'll talk about in terms of what can be done with the things that are inherited, but you know that will come a little bit later. All right. Now it is important to note that the student, which is the child, is a more specific version of the person, which is the parent. Okay. And what makes it more specific? It's going to have some things that the person will not have. All right. Question? I thought I heard somebody asking something. Okay. All right. So here are some other examples, and these you probably can relate to specifically. In the first example here, we have vehicle, which is a generic name for what drives around. Yes. And then we can always say a car is a type of vehicle. We could also have another inheritance relationship where we have, let's say, a van. I'm not doing so good on that, but I could say here a van, and then I have a van. Now, whatever makes a van different from a car, right? There are some base things that both vans and cars will have because they are vehicles. So maybe both of them will have a chassis number, for example, or a registration number, right? Or a manufacturer name, okay? But then a van might have, you know, a different type of form factor, right? And a car might have something different, right? Now, here's another example, and usually when you're drawing, instead of drawing it the other way that I did a while ago, you do it a little bit more controlled in this way. So notice we just create one triangle, and then we share it between novel and dictionary. It's as if we would have drawn it, you know, with its own like that, right? Doesn't change anything. Yes? Now, dictionary is a book and novel is a book, all right? And book is the superclass, and novel and dictionary are both subclasses, yes? All right, so any questions, Barbados? No. Good. All right, a programmer can tailor a derived class as needed by adding new variables and methods, all right? Or they can actually modify those things that are inherited, right? And we're going to talk about how you do that. Now, a major benefit of software, of inheritance, is software reuse. Notice something, especially with our last example, right? A book might have some specific things about it. Now, remember, you can have all types of classifications of books, yes? But as we know it in general, for example, one thing that a book must have is what? A title. Another thing is an ISBN. Another thing might be an author or an editor, okay? Those things might be part of the book class. Now, a dictionary may have no words, amount of words, right? Amount of definitions and whatever else, while a novel might have chapters or theme or, you know, whether it's romance or whatever it is, yes? So those characteristics might be something different, all right? Now, all of a sudden, instead of creating a dictionary class, which has all of the things that would have been in a regular book and the things that are in dictionary, and then we create a separate class called novel, we instead create one class that have the general things about all books, and only the differences are actually put in the other classes. So basically, dictionary is used in book, and novel is used in book, but we only wrote book once. So we are reusing what is in book, yes? Instead of rewriting those things that could be of use. So we are sharing, yes? And that's a big, big benefit. All right? By using existing software components, we can create new ones. We can capitalize on all the effort that went into the design, implementation, and testing of existing software. Now, let us talk a little bit about what is actually inherited when you attempt to do inheritance. Generally, one way of viewing inheritance is that the child class has a copy of the parent inside of it. Okay? It's like composition, but they are not the same. And some people actually suggest using composition in some cases instead of inheritance. For whatever reason, we know that inheritance is a fundamental principal concept. So in a sense, what I'm saying is that the inheritance relationship between person and student is almost like saying student has a person inside. Okay? It's almost like saying that. Now, what can be accessed in the child depends on the visibility modifier of the class. Remember we talked about visibility modifier maybe a couple of weeks ago, a couple of lectures ago. We talked about the private, the public, and we said we'll talk a little bit more about protected later on in the course. And so today we're going to talk a little bit about protected. So first thing to note is that private members of the superclass cannot be referenced directly by methods in the subclass. So even if the class inherits from the parent, you cannot access the private members without using the getters and setters because they are private. Okay? They can only be referenced to methods, which are generally public. Now, public members can be accessed directly in subclasses. This is okay for methods, but not good for attributes. All right? Because, of course, this would be violating the principles of encapsulation. And so, let us look at this example then. So remember we just drew the diagram to show person and student. The methods in the student class would have been get name, get DOB, and get major. But think about it. If you look at my example here, you realize that only one method is there. Yes? Obviously, the others here came from the parent class. Yes? Get name and get DOB. So the attributes also, right, come from the person class, and we realize that we have the first three, right, which are these here, and then the two that are specific, which is ID and major to student. Right? Everybody with me so far? Now, all methods in the superclass are inherited by the subclass, except the constructors, right? Constructors are not inherited from the superclass. I said all method, but implicitly there is something here that you have to be aware of. Just like how private attributes, right, are inherited but cannot be accessed directly. If a method is in the superclass and it's declared as being private, same applies. So even though it's inherited, it can be used. Yes? Good. All right. Now, if we want to allow the child class to reference a variable or method of the parent class in the child class, then the protected modifier can be used. Yes? Now, what that actually does is to make sure that the child class can access it, right? But to all other classes, that method is now not accessible, right? Except for those methods, for those classes that are in the same package, okay? So a protected variable is also visible to any class in the same package as a parent class, okay? And of course, we denote that in UML by using a hash sign, as you would have seen here. Yeah? Yeah? All right. So here's the example now. Same thing again. Everything is inherited, right? Now, it just means now what we have done, we have made these protected. Notice the hash sign now there. Right? It means that when I'm inside of my student class here, I can directly reference these. So I could say, for example, inside this class, I could say first name. I'm not writing well today, sorry. Right? Equal, 5 for argument's sake. It's not writing well. All right. So basically, this is horrible. So I could actually access the data members directly because I have now made them protected. All right. Questions? No? All right, so it's important to understand one subtle issue related to inheritance and visibility. All variables and methods of a parent class, even the private ones, are inherited by its children. Okay? As we mentioned, private members cannot be referenced by name in the child class. However, private members inherited by child classes can exist and can be referenced indirectly. Right? That's the most important word here, indirectly. Yes. All right. Because the parent can refer to the private member, the child can reference it indirectly using the parent's methods, and the super reference can be used to refer to the parent class, even if no object of the parent class exists. That's interesting. All right. So I create an instance of the child class. I don't need an instance of the parent class to be explicitly created if I extend, yes? So I can basically assume that now the child class gives me access to the parent class without explicitly creating an instance of it, all right? Now, we might not want things to work the same way, right? In the child class as in the parent class, and so we get an opportunity to do what is called overriding methods. So a child class can, what we say, override the definition of an inherited method in favor of its own. So that method has to be either public or protected in the parent class. Okay. The new method must have the same signature as the parent's method, but can have a different body. Okay, I remember we talked about method signature some weeks ago. It has to do with the parameters and the order, right? Of the parameters that are included, and of course, the name has to be the same. The type of the object executing the method determines which version of the method is invoked. That's important for you to note in an example which we're going to do in a little while. A method in the parent class can be invoked explicitly by using the super reference. So if I have a method called toString in the parent class, and I have a toString in the child class, I can say super dot toString, and that is going to invoke the one in the parent. But if I just say toString, if the object is of type for the child class, which in our case would be like student, then it is going to run the version in the child class. But I can force it to run the version in the parent class. All right. Now, if I have a toString in the parent and a toString in the child, essentially what I've done, if they have the same signature, is to override the one that is in the parent. Okay? Because if the object type is for the child class, it's going to run that version. If the object type is for the parent class, it's going to run that. And we're going to do an example in a moment. Now, the super reference is particularly useful when we are invoking the constructor of the parent class. Remember, we said that the constructor is not inherited from parent to child. Okay? Now, just a note here, if a method is declared with the final modifier, it cannot be overridden. Okay? You're going to get an error. All right, so here's the example, and I hope you pay attention to see the difference. Right, Barbados, you with us?
Yes, sir.
Good. Tell me what's the difference you see here. Look closely, and you also here, and tell me what do you notice. Let me focus your attention. Don't look over here. Don't look over there. Look over here.
Look at there.
I think you're focused on where I tell you not to look, right? Well, assume now that that is a representation of that, and that is a representation of that, right? So my UML is telling you there's a person, there's a student class, and my toString at the top is written inside person, and my toString below is written inside student. It says it there, but just making sure you realize. Okay? Now down here I create two instances, right? Two instance variables. Two object variables. One of type person and one of type student. So when I send p.getName, which of the get names is executed? Barbados. This one?
No.
Okay, good. This one, right? Now, and then when I say, why is that so? Because P is of type person, so it's a get name that is in person that is going to be executed. But S is of type student, so this get name is going to execute this one. Yes? Now, notice one prints John Brown and one prints Brown John. Bet you didn't see that. So one print the first name followed by the last name, the other one print the last name followed by the first name. So this is how you could think about, okay, let us say that we have an application and in some cases you want to print out the name in alphabetic order and you want to order it last name first, then first name. Right? Then you could always play around with which of these you use. Yes? Even if you're in the child class, you could actually say super.getName to invoke explicitly the one in the parent class. You with me? Alright. Now, you can apply overriding to instance data. And this is called shadowing variables. It's not a good idea. It creates all kinds of confusion and we won't spend time on that. Now, just to note, oftentimes people mix up overloading and overriding. So I want to clarify. Overloading means multiple methods with the same name in the same class, but with different signatures. You with me? So, what this actually means is that inside my class, I could have a method called print name. Okay? That takes in an int. Okay? And then inside of my method, I have another, inside my class, I have another print name that takes in a string. See that? Now, that is overloading. Okay? Now, in this case, the version of print name that will be run is dependent on what input I pass in. So just like with constructors, remember, you can have a constructor that has in different things. So you can have multiple versions of the constructor, one that takes in nothing, one that takes in all the instance variables, one that takes in some of them, and so on. That's overloading, right? Same method, name, in the same class, but different signatures, which means the parameters, type, and sequence are different. Overriding, which we just spoke about, deals with two methods, one in the parent class and one in the child class, that have the same signature. Note that they must have the same signature. So overriding lets you define a similar operation in different ways for different object types. And what you mean by different object types in this case, remember now, if you inherit from one, the parent is a different object type from the child. Yes? And that's what we're talking about. So please don't mix up overloading and overriding. From time to time, you may be asked to override a method or overload a method. And remember that you can do both of them. Because if you're in a child class, you can do overloading, but you can also do overriding in that same child class. You with me? Yes? So just don't confuse both. Yes? All right. So help me now. Barbados, the first 3 are yours. What do you say? True or false?
True. True.
True. Next one? I'm not hearing. Say that again.
False. False.
False. And the next one?
True.
True. All right. WJC. True or false?
False. True.
False and true. Let's see if you're all right. Are you?
Yeah.
All right, good. So then, let us look on class hierarchies, and this is important as a Java programmer to know, all right, because it's going to help you. And you're going to see some things that are stated here. You may have seen a few of them already, right? All right, so a child class of one parent can be the parent of another. Child forming a class hierarchy. Yes? So let us quickly dissect this diagram, okay? So basically a reptile is an animal, so is a bird, and so is a mammal, okay? But a bat is an animal, which is a mammal, right? And so bat basically in this hierarchy is going to inherit everything from animal and mammal. Now, very important thing to note for implementation purposes. Bat doesn't interact directly with animal. Okay? Bat only interact with its parent. The relationship that goes up, mammal has to deal with animal. See that? So bat only knows its parent. It doesn't know its grandparent. In a sense, right? Although, because, well, it expects that mammal will deal with everything above. So although bat is going to inherit everything in the hierarchy, it is not dealing with anything above its head. Right? Now, of course, animal, right? The parent of reptile, bird, and mammal, right? Any of the classes here that you instantiate can be considered in the is a relationship. Okay? So we can say reptile is an animal, bird is an animal, mammal is an animal. But when you get down here, right? Bat is a mammal. You don't say bat is an animal, bat is a mammal. And then you can say no, a mammal is an animal. Okay? The reason why I point that out because it has implications for when you're programming. Right? I don't want you to make the mistake of thinking that because bat down here falls in the hierarchy coming straight down, that bat has to deal with anything above itself. Right? Mammal is to deal with animal and bat is to deal with mammal. Okay? So I've seen students try to invoke the constructor of the grandparent. We don't want you to make that mistake. Okay? That would be incorrect. Alright? Alright, so two children of the same parent are called siblings. Common features should be put as high in the hierarchy as is reasonable. Okay? So if things are shared between children, right, make sure the parent has those attributes and methods. Okay? An inherited member is passed continually down the line, therefore a child inherits from its ancestor classes. And there is no single class hierarchy that is appropriate for all situations, so it comes down to your own design. Now, inheritance has many implications. Let us consider, for example, both student and person are of the same type of person. Sorry, both student and person are of type person. We realize that, right? Because the inheritance relationship we had, right, was person, right, and student. Right? And student is a person. Okay? Which means that they are of the same type. Cool? Now, yet each responds to the same command. Remember the example of get name differently. Because remember, if we had created person P and student S, and then we say P dot get name, and then we say S dot get name. And guess what? The two of them run a different version of the get name. One ran it from the parent class and one ran it from the child class, depending on which one was the type. So P was a person, so it ran the get name in the person class, and S was a student, so it ran from the student class. Now, we have to note that the object type is what determines which version of the method gets executed. Right? And we saw that clearly here. These concepts are really covered in a future lecture, which is going to be on polymorphism. And we will show you a number of nuances associated with types, overriding and overloading. Now, consider also an application that can be extended to create a new application with some added new features. All right? And for those of you who are paying attention to what's going on in the development community, you would have seen the rise of what are called application frameworks. All right? What are these? These are very powerful implementations of generalized solutions from which you can now inherit and do your customizations. Right? So that is now OOP, right, at work, right, where you are reusing what exists and adding on your own little variations by inheriting what exists and just making modifications as you go along. Okay? Very, very powerful concept. So OOP practices have been more or less revolutionizing how we develop applications through application frameworks. All right, now that's it for this half. Okay, so welcome to lecture 6B. We're going to look at inheritance specifically in Java, how that is implemented. And that is going to be important for you to be able to demonstrate your understanding of the concepts which we covered in 6A. All right. So now we're going to look at the keywords in Java, and then we're going to look on the Java inheritance hierarchy or the class hierarchy in Java, which is going to guide you when you're doing some more advanced development work as we go through the course. All right, so in Java, we use a reserved word called extends to establish an inheritance relationship, right? And so, here's the example. We have a class called car, which extends vehicle, right? Notice the class is declared the same way here as we would have done before. Now, the only thing that is different is that we're extending vehicle, which means that vehicle must have existed before. Okay? So we write the vehicle class and then we extend it using car, all right? Which is now representative of the example we were discussing in the first half. Now, the new class car will have the methods and attributes of the vehicle. So car is a vehicle. All right. And the same thing with the person student class. We would have to create the student class first, the person class first here, and then down here we say public class student extends person. Okay, and then we start our body. All right. Now, in the following example, we're going to look at book and dictionary. In other words, dictionary is a subclass of book. This means that the methods that are identified, that are defined in book class are inherited by dictionary. So here we go, creating the book class here, and book has a protected instance variable called pages, and that is automatically set to a value of 1500. And then it has a method set pages and get pages. Okay. Notice we don't have any constructor defined here, so the default constructor is assumed. What that means, the default constructor takes in no parameters. Okay. Now, here we have dictionary, which extends book, right? So this is a subclass of book. And here we have a private variable called definitions, and we put the amount of definitions there. Okay. Now we have a variable called, a method called compute ratio, which returns a double. Okay. Now notice here, this variable definitions is declared in the subclass, and pages is inherited from the parent class. Yes. Notice it can be accessed directly. Why? Because pages was declared as protected, not private. Yes? Very important to know. All right? Any question? And then that's the rest of the class, the child class, of course. Now, this class we're going to be using to create an instance of dictionary, and we're going to be playing around a little bit. So here we go. We have a class called words, which is going to be more like a Java class. And inside of it, we have our main method. And so now we create a variable of type dictionary, which is called Webster. Okay. And then we instantiate that object to be of type to point to an object of dictionary. Okay. Now, when we say Webster.getPages, of course, that is calling the get pages from dictionary, which is not get pages from dictionary. Sorry, it's calling get pages from the parent class, right there. Everybody see that? Yes. Get definitions though and compute ratio are part of the dictionary class here and here. Okay. So here we are not explicitly calling the parent, right? But it's a parent method that is executed there. Why? Because we didn't override it. Okay? So in a sense, what ends up happening, the object type is dictionary based on what we defined here. Yes? Now, when the execution is going on, right, the object type is used to say, okay, which version of the method be run. Now, when the compiler looks and see that there's no get pages in the child class, what it does, it looks in the parent class for that version. Now, if there was a get pages inside the dictionary class, it would invoke that one and execute that one. We'd have to explicitly tell it, don't use this one, use the parent version. But because there is none, right, when it looks, it doesn't see any in the dictionary class, it looks to the parent. And if it didn't find it, what would happen? You get a no such method exception. Right? Remember exceptions from last time? Good. All right, so the super reference. I was talking a lot about the super reference in the first half. Similar to the use of the this, where variables and methods have the same name, right? Because of what we were talking about earlier, overriding right, and overloading. Now, this keyword is most often used to invoke the constructor of the parent class, right? But I also mentioned how it could be used to invoke any other method of the parent class, okay? Now, please pay attention to this. Whenever we have a class that extends another class, all right, the constructor of the child class, as we see here, the constructor of student, right, takes in all of the variables required for the constructor of the parent class and all the variables required for the constructor of the child class. Everybody see that? Yes? Now, in our implementation before, we did not declare a constructor inside of the book class. Remember that? And therefore, we did not have a situation where we needed to pay attention to that detail. All right, let me just proceed and use this example instead. All right, notice here, the super keyword is used, and this super keyword invokes the constructor of the parent class. Everybody see that? We're assuming that the parent class constructor takes in all three variables here. And so that's why we have a first name, a last name, and a date of birth. It is important to also note that in Java, that line of code has to be the first line of code in the child class constructor. If it comes after, it is going to generate an error. Okay? It's like saying that if you are inheriting from me, in order for you to exist, you need to make sure I am set up first, so that you can take what is set up and add to it. Yes? That kind of principle. You can't have a child without a parent. Right? Yeah? Now, and of course, do you notice we actually have the other variables. So my constructor now takes in the things for the parent class plus what I need for my actual child class, which is student. So it takes in all the variables for both parent and child. That's my constructor. All right. And I told you already how you could use the super keyword to invoke a method from the parent explicitly. Okay. Now, if you don't put the super reference, right, Java will attempt to invoke the default constructor, which is the null constructor. Now, think about it. If I have no constructor in the parent class, then there's nothing, no problem, which is the case with the book and the dictionary. There was no constructor, so what Java did was to automatically invoke the null constructor. But if I have a constructor, it automatically means that I have overridden, right? I've overloaded the default constructor. And that way now I must use my super. So when I was going back to the example, in my dictionary class, I did not have a super for my constructor. Neither did I have a constructor for my dictionary. It automatically means that the null constructor is assumed. Now what happens is that I don't need, because my book doesn't have a constructor. Notice I have only mutator and accessor. So I have no constructor. When I go to dictionary, I don't need the super reference, because Java automatically invokes the null constructor once that is so. Now, once I have a constructor though in my parent class, I have to invoke it using the super reference. And super must be now seen as calling the name of the constructor, which means that the parameters that the constructor takes in must be passed into super as a method. All right. So here's the example. We have book 2, which has a protected member pages, and then it has a constructor. Now this constructor takes in number of pages. Okay, note that, right? And then we now have 2 methods. We have set pages and we have get pages inside book 2, right? Now we have dictionary 2, which extends book 2, right? And it has 1 member. Notice the first line in my dictionary constructor. See my constructor? The first line is super, which calls the constructor in my book. Notice the constructor in my book 2 takes in 1 value, which is an integer. Okay? So when I call super inside of my child class, I have to pass in the same parameter, which is of type int. But also my dictionary constructor also requires num definitions, so I also pass that in, and this variable, which is a part of my child class, dictionary 2, is updated in the same construct. Okay? So the first thing you do is call the parent construct. Any questions? Everybody happy? Great. All right, and you know, we have some more methods, compute ratio, set definitions, and so on and so forth. And now we can now use our driver class. Now we create an instance, an object type Webster, so an object Webster, which is of type dictionary 2. And now when we call dictionary 2 constructor, we have to pass in 2 things based on what we defined earlier. The constructor takes in 2 things, num pages and num definitions, right? And so now we can say Webster.get pages and Webster.get definition and so on, and those will invoke the versions of the method that associated with the object type. Okay? Any questions? Everybody happy? Good. All right. Override it. So a child class can override the definition of an inherited method in favor of its own. The new method must have the same signature. We talked about that. We're just going to say now how it is done in Java. So here's the example. We have a class called thought here, which has a method called message. And all this does is to print out, I feel like I'm diagonally parked in a parallel universe. All right? And then we have a print line, which prints an empty line. Okay? Then we have a class called advice, which extends thought. Yes? And now we also have a method called message. Okay? And in this method, all we do is print out warning. Dates in calendar are closer than they appear, especially when it comes to your coursework. All right? And then we print a new line. Okay? Now notice here, we explicitly call the message method from the parent class. Yes, that's what super does. Notice, advice extends thought. So here we explicitly call message from the parent class, which is thought. Yes? Any question? Notice, same signature as the parent class. Yes? Public void message, no parameter. So now we create a class called messages, which has our main method here. And we create an object of type thought, and we point it to a new thought object. Okay? And we do the same thing with advice. Now, if we execute this line of code, what will be printed out? What is the object type? Thought, right? So this should print out, I'm parked diagonally in a parallel universe, right? And they should print out. It should print out both messages because we printed out warning dates are closer, and then we explicitly printed a line and then printed the other message. All right, so our result should reflect 3 messages. This comes from thought, and these 2 come from dates or advice. Okay? Any question? Simple enough example. Any question, Barbados? Everybody over there happy. Very good. A method in the parent class can be invoked using the super reference, but not if you use the final modifier. And that's a way of forcing all classes that inherit from the parent to use the one in the parent. Yes? Let's say, for example, in a banking situation, we have a tax rate, calculate tax, right? And calculation of tax is going to be always multiplied by the percentage that the government indicates. But everybody is going to have to pay that tax, right? But we have all different types of things in a inheritance hierarchy. But we don't want any of those child classes to be able to modify how tax is calculated, because that's a serious business. We could write that method and make it final. And so we know it doesn't matter when we're calculating taxes for which of the classes in the hierarchy, it is always going to be the one in the parent class that is used. All right? So that's one way of forcing things to be to be done a particular way. All right? Now the concept of overriding can be applied to data, and that is called shadowing. I told you that already, right? But that creates confusion. Any questions? Okay, a happy group, good. Now, let us talk a little bit about the Java class hierarchy. Now, there's a class called object, which is defined in the java.lang. I remember we said that every program that you write, right, automatically imports the java.lang library. Okay. Now, so we don't have to do that explicitly. But remember, we were talking about, for example, string and scanner, and which of them is a part of the Java library, the libraries that we need to import. All right. So java.lang is always imported in our program, in our code. Now, all classes are actually derived from an object class, which is basically at the top of the class hierarchy. Okay? Just think about it this way. No matter what the class hierarchy you have, right? At the very top of it, there is a class called object, right? Okay? So if you build your thing, right, with person and student, and this is your application down here, just know that there is a relationship with an object class at the top of the person. Okay? So it basically means that every class in Java is an object. You with me, Barbados? Yeah. Good. Now, it is the reason why sometimes when you are reading the API documentation, you will see object, object, being referred to as the type, okay, that is either returned or passed into some methods. You've seen that in the documentation, right? All it is saying is that any class will do, right? Because any class you can write, including the object class, I mean, any class is going to be an instance of the object class, or is an object. Okay? So the object class is the ultimate root of all class hierarchies. Okay? Now, object class contains a few useful methods which are inherited by all classes. Right? So the toString is one of them, which is why every class has a toString method, and you have to override it, right, if you want it to behave a particular way. So in the string class, for example, toString is overridden, right? Now, if you don't override it, what is going to happen is that the default version from the object class is going to be used, and what that actually does is to return a string that contains the name of the object's class with a hash code. All right, and you don't want to use that to necessarily see that, which is why every class you write, it is strongly encouraged you write a toString method. Right, the toString method takes in nothing but it returns a string. That's a signature. Okay. Now the object class also has an equals method. And equals, basically, we can override that in any class to define equality in a more precise way and appropriate for the application. If we don't, then the equal method is going to return true if the two objects are pointing to the same references or if they are aliases. All right. Now, from the string class, we know that there's an equals method also, but that has been overridden. And so strings are compared a particular way, which is different, which basically is true if the objects contain the same characters, and not just if they are pointing to the same location. Okay? A few more quick words. Single inheritance is supported in Java, which means that a child can only have one parent. All right. There's a way to get around it, but that's when we talk about interfaces and polymorphism. And some of the things you want to be careful of too is not having the same variable names in multiple classes that inherit from each other. Okay. That creates what we call collision. All right. Now, in general, multiple inheritance is not needed, and Java does not support it directly, but it can be accomplished indirectly. Okay, and we will show you that in a future lecture. There are a few instances where, you know, a class needs to have more than one set of characteristics, and there's an example. An employee in an organization is a person, so the employee can be derived from the person class, but that employee might also be a citizen in a country which has a tax number. Yes, and so the issue is here, we might need to inherit from both person and citizen. Okay, and this causes some multiple inheritance, but we will see how to do this a little bit later. All right. And just the quick check, I gave it away already. Eh? The methods that are defined in the object class, the toString, equals, and there is a clone which basically creates a copy of an object. All right. Okay, that's about what we had to talk about today. I mean, if you have any question, I can always take them. Barbados, you're up first if you have any questions. Not hearing you so well.
We're good. No questions.
Oh, no questions. You're all happy. Great. All right. So